Hello students, this is a lecture about calculating empirical formula. We've already talked about the definition of empirical formula, where it's a ratio of elements and it will be the simplest whole number ratio. Here in your notes, in your topic notes, if you'll notice, I have a couple things for you to look at. You have, here's a little saying: change percent to mass to mole, divide by the small, and multiply to a whole. That basically goes over the steps. And if you'll look, I have in your notes, and you can look at this later, I have the steps here, number 1 through 4. I'm going to switch to the next page of this handout and go to where we actually do a problem. And so here is an example of a problem. And then I will do one by myself. But let me explain this one. In this problem, notice that we have quantitative analysis shows that a compound contains 32.38% sodium, 22.65% sulfur, and 44.99% oxygen. Find the empirical formula of this compound. I want you to notice that I took these numbers right here. Here's sodium, sulfur, and oxygen. They're in percentages. I'm going to change them directly to grams. The reason I can do this is because when it's in percentage, I can assume whatever size sample I want. So let's assume a 100-gram sample. That makes the math real easy. 32.38% of 100 grams is 32.38 grams. 22.65% of sulfur, if you assume a 100-gram sample, is 22.65 grams of sulfur, and so on for oxygen. So I literally just take my percent sign off. I'll put my grams on because I'm going to assume a 100-gram sample. If there's another size sample, I'd have to multiply by that percentage. Now, since I have 3 different elements, in order for me to combine these elements together, I have to be in a unit that are compatible with each other. And so I have to change my grams to moles. I need to be in moles before I can compare one unit to another. I can't do that in grams. So my first step is to do a mole conversion, and I have to do it for each problem, for each one of those substances. So first, right here, I'm going to do a mole conversion problem. Now, we just spent 2 days on mole conversions. So here I have my 32.38 grams of Na, and that gives me, I look at Na on the periodic table, and I get 22.99. And when I do that, I get this as my answer. So the red arrow shows you the answer to that math problem. I do the same thing for each. I take my sulfur, divide by my mass of sulfur, and I get 0.7063. I do the same thing for oxygen, divide by the mass of oxygen, and I get 2.812 moles of oxygen. So currently, I have 3 answers. I'm going to change pen colors. So this is the answer for the first problem, this is the answer for the second problem, and this is the answer for the third problem. Once I get to that stage, I have moles, I can now compare them to each other. What I'm going to do is I'm going to pick the smallest of those answers. Out of those 3 answers, my smallest one is right here, 0.7063. Since that's the smallest, I'm going to divide everything by that number. If you'll notice here, I said 1.408 divided by 0.7063, and I get the answer of 2. Do the same thing here, I get the answer of 1. Divide by the smallest here, I get the answer of 4. Notice that they are whole numbers. If they are whole numbers at this point, then I can take those numbers and they become subscripts. Notice that Na now has a subscript of 2 right there. That S now has a subscript of 1 right here. And oxygen now has a subscript of 4 right there. that gives me my empirical formula, NO2SO4. I want you to notice that empirical formula is a formula. It is not a number. It's not a math answer in the form of number and units. Now, I'm going to clear the sheet and go to the next page. Here's an example where I do not get the same information. I do not get a whole number. So again, in this case, I have 10.15 gram sample of a compound. It has phosphorus and oxygen in it, and it tells me that the phosphorus is 4.433 grams. So here I have the 4.433 grams of phosphorus. Now, how did I get this 5.717? Well, I took my original sample of 10.150, subtracted my phosphorus, 4.433 grams, and got 5.717 grams of oxygen. I can do that because phosphorus and oxygen were the only two compounds in this sample. I'm going to follow the same pattern I did previously. The first thing I'm going to do is change grams to moles. So I did that here. I got this answer of 0.1431, and here and got 0.3573. Next step is always to divide by the smallest. This is my smallest here, so I divided both of them by 0.1431. Here I divided by 0.1431. But when I got those, I didn't get a whole number. I got 1 here, and I got 2.5 here. 2.5 is not, it's got to be very, very close to get a whole number. So I can't use 2.5 because I can't have a formula that has P1 and O 2.5. In my formulas, they have to be whole numbers. And so I can't use that. So what I'm going to do is I'm going to multiply by some whole number to get a whole number. In this case, if I have a 0.5 here, if I multiply by 2, it becomes, half becomes a whole technically. And so if I multiply by 2, I get 5. The problem is if I multiply this one by 2, I must also multiply this by 2, and I get 2. That now becomes my subscripts, and I get P2O5. It's very important that you pay attention to your units there. I mean, to your numbers, make sure they're whole. So, let's for example, I say I got a fraction of 0.25. I would multiply that by 4. If I got 0.33, that's the same thing as a third, I would multiply by 3. 0.5, of course, is a half, so I multiply that by 2. What I want to do now is I want to stop and give you a problem, and I want you to stop the recording, stop the video, and I want you to try it on your own, and then I'm going to do an example, do it for you on the video. So if you will take the time to go to the next problem, let's show you an example. Right here is task 7, and what I'm going to do is I'm going to do the first one, and I'm going to ask you to do it on your own before you look at the video. So if you'll take just a minute and try that before you do the video, and then I will have the answer for you. Okay, now here's the problem that you hopefully just finished. You had 72.2% of magnesium. I'm going to assume a 100 gram sample and take that right to grams. I'm going to look this up on the periodic table and get 24.3 grams of magnesium per mole of magnesium, and that's going to give me 72.2 divided by 24.3, and I'm going to get 2.97, and because it has 3 significant digits, I'm going to stop there with 3 moles of Mg there. Here, nitrogen has a mass of 14, so I'm going to say 27.8 divided by 14, and that's going to give me a mass of 1.99 moles. All right, now remember the next step is to divide by the smallest, so I'm going to take this one and divide by 1.99 moles. I'm going to take this one and divide by 1.99 moles. And of course, this is going to equal 1, and 2.97 divided by 1.99 equals, it actually equals like 1.49, but it's very close to 1.5. So I'm going to put 1.5. That is not a whole number. So now I multiply this one by 2. And if I multiply this one by 2, I have to multiply this one by 2 also. And so my numbers that I'm going to use are 3 and 2. There are 3 magnesiums, Mg3, N2, and that is my answer. When you're looking at these, just remember that the steps are pretty much always the same. If you're not in grams, if you're in percent, you want to change that directly to grams. You're always going to go from grams to moles. After you find moles, you're going to divide by the smallest. Then, hopefully you get a whole number. If you do get a whole number, that becomes your subscripts, and you put that into your formula, and you're finished. But if you do not have a whole number, you will have to multiply by some number in order to make that be a whole number. And then those numbers become your subscripts. I hope this was helpful. Take time to look over it. Remember, you can pause at any point and stop if you don't understand something. When we get back to class, we'll practice this. Thanks.